All right, guys, good morning. Hopefully, you've got my email. All we're going to do today in this lecture, well, it's like mini lecture, is tie up some loose ends about the 3.1 section. We've kind of been talking about this in some of the do nows and throughout the year, mostly because it's kind of hard to avoid if you want to talk about statistics intelligently. And that is how shape of a distribution can affect mean, median, and mode, and how that's going to help you decide which one of the statistics, mean, median, and mode, would be best used to describe the central tendency of a distribution, of a data set. So let's read through this together, and you should, in some way, shape, or form, include this in your notes. Okay? So the shape of distribution can greatly impact the measures of center. All right, remember from chapter 2, the most common shapes are bell shape, right? Left skewed, and right skewed. So just make sure that that's clear. This one isn't labeled. This is, of course, left skewed. Sometimes it's called negatively skewed. Okay, so as you can tell, if we have a symmetric distribution, the mean, and median, and mode are actually all the same, relatively same value or the same value, located at the center. So in this case, it wouldn't make a difference which one you choose, although mean is probably the most appropriate and going to give you the most accurate measure of center, seeing as how it's going to be symmetric and bell-shaped. Okay, so we discuss mean when we discuss bell-shaped distributions most often. That's different when you compare it to a right skewed or a left skewed distribution. As we've talked about, right, these unfrequent yet extreme values in comparison to the center, right? If you were to look at the center of this distribution, I would say it's somewhere like maybe here or here, right? The most central tendency. The mode, of course, is our highest peak. The median would appear somewhere around here. Wait for this thing to focus for a second. Okay, let me try that again. Okay. Oh, all right. So the mean, however, is really pulled. So the mean is pulled up from where it was in a symmetric distribution away from the median by this data there. So that's why I've always said it's this data which is doing the skewing. What is it skewing? It's skewing the mean to the right. So in a situation like this, the mean is not really the best measure. The best measure might be the median, or arguably the mode, depending on the circumstances, I suppose. Okay, and the same discussion holds true for left skewed distributions as well. So let's go through these properties and see what's most important here. Of course, the mean is found by using all the values in the data set. Sometimes that's good, sometimes that's bad. Right, that means that the mean is going to be affected by outliers, right? The mean varies less than the median or mode when samples are taken from the same population, and all three measures are computed for these samples. Okay, so the mean is going to give you more of a consistent value if we're looking at samples taken from the same population. The mean is used in computing other statistics, such as variance, so the mean is important to have if you want to discuss other types of measures of the distribution, other types of statistics. So it might be nice to have that. The mean for the data set is unique, not necessarily one of the data values. This is true, right? The mean is computed from data values, doesn't have to necessarily be a data value. This is different from the median and mode, which could or could not be part of the mode has to be part of the data set. The median could be part of the data set. The mean cannot be computed for the data in a feature distribution that has an open-ended class, which means that it means that there's no bound for the class, right? Like 80 and above, right? That means that we don't have a end of our class to find the midpoint for, right? So we can't find our weighted mean. In that case, the median would have to be used. So if you have an open-ended class, meaning you don't have well-defined class boundaries, like those age tables we looked at before using COVID, right? They said like 70 and above. You have unequal class widths, things like that. The median is affected by extreme high values or low values, called outliers, right? It may not be appropriate average in these situations. So that's an easy one. If you see an outlier, or if you see outliers, it's pretty clear that mean is not the appropriate way to describe the data set. Median would probably be more likely. So usually our choice boils down between these two. What's the safer bet? The median's always the safer bet. The only time that I would go with the mean is really if you're dealing with a distribution like this, a bell-shaped distribution, which happens a lot. It doesn't have to look exactly like that. It could be approximate, right? But if it's a skewed or you have outliers, median is what you're going to be choosing. So, of course, median is used to find the center or middle value of the data set. Okay, the median is used when it's necessary to find out whether the data values fall into the upper or lower half of the distribution. That's kind of nice to know, whether you're in the top 50% or the bottom 50%, right? The median is used for an open-ended distribution, meaning you don't have bounds to your distribution, perhaps, right? And you're getting more data values as you compute. The median is affected less than the mean by extreme low or extremely high values. So it's resistant. As we looked at that Jeff Bezos example, right? It's resistant to outliers. Okay, so the mode is used when the most typical case is desired. All right, this could be used usually if it's like categorical. So you'd use the mode usually if it was categorical. Okay, you'd use the mode usually if it was categorical. The mode's easiest average to compute for sure. The mode can be used when the data is nominal, right? That's what I just talked about, nominal or categorical data. The mode's not always unique. Data set can have more than one mode. The mode may not exist for a data set. So, all right. So then we discussed the mid-range. I know that my camera's already frozen on me. I'm just gonna roll with it here because I'm almost done. So the mid-range is easy to compute. It gives the midpoint, but it's also affected by extremely high or extremely low values. I would only use the mid-range in the event that I have like a relatively uniform distribution. But to be honest with you, I've never really seen it on its own. It's always used as more detailed specifics in a conjunction with one of these other ones. Even though it is a measure of central tendency, it gives people an idea about what the spread of the data is as well. But I've never seen it just by itself. Okay, so uniform distribution for mid-range, the mode for categorical, the median for left, right skewed, or outliers, and the mean is for for symmetrical bell-shaped distributions. All right, guys, get that ALEKS assignment done as best as you can. I know it's a long one. You can do it as many times as you'd like. It's going to count as 2 homework grades, and then we'll pick up here tomorrow. Okay? Have a great day. Be safe. And again, sorry that I'm out. I'm barely standing up. Sitting down would definitely, send me to the ER. So I'm not going to do that. Hopefully I'll be up and running tomorrow. Take care, guys.